All right, we're back and picking up right where we left off. Going to open up another cold can, and is it a superb idea that I open cold cans and then dive into complex things like computing problems and stuff? I don't know. You can be the judge. But basically, talking about sort of a foundation of computer science, which is variables. The first one, the 2 videos ago was a little more coherent. That last video was sort of a dump, a data dump, if you will. Different topics. We clicked around a lot, clicked on a lot of crap. Started throwing around some phrases and some concepts that, unless you have a background on that sort of stuff, may not be super clear. But there's a method to the madness here. We threw around a lot of concepts. Are we going to go over every single one? No, I'm not gonna. I'm not gonna go over flip flops and stuff. Um, or electrical engineering and things like that. Instead, we're going to sort of bring this back up, and we're going to delete all this. We're going to go bring this back up. Programming languages, variables, and the abstraction of variables over memory locations. So let's look up a variable in Wikipedia. We have variable in mathematics. We have variable in computer science. We'll go to computer science. You can look up variable in mathematics. It's not crazy if you're familiar with just rudimentary algebra. Um, basic geometry, things like that. The variables should be no big thing. A variable in computer science is generally no different than what a variable is in mathematics. It's just that the way that the variable is implemented has a more a functional underpinning than it does in mathematics. Now, we're going to start reading through this article in a second, but let's try and illustrate what I just said. So in mathematics, you could just x equals 5. That's it. There's nothing under the hood of x equals 5 because math is something that's just basically on a ridiculously abstract level. Math is something that exists in our head. Um, Obviously, either there's a foundation in nature or natural. I'm sorry, I can't talk. In nature and physics and natural laws and things like that. But x equals 5 is an abstract concept. There's no implementation of x equals 5 under the hood that we're aware of, or at least we're going to put forth the idea. There's nothing under the hood. So in mathematics, x is equal to 5, and that's it. There's nothing else. In contrast to that, in computer science, if you say set a variable to 5, there's a variable x, we're giving it a value 5, we're expressing this exact same concept that we are up here, and that's it. Except it's not. So we know computers have memory. It's a fundamental concept. It's why people go out and they buy RAM sticks and things like that. My computer needs more memory. Why does it need more memory? Well, because it can cram more random shit, into the memory. The more memory it has, it can access that memory, and that's the general concept. Cramming more shit into more memory. That's the name of the game, or at least that's the name of one game when it comes to computers. So clearly, that's not it. We can get rid of that. So what do we mean when we say that we're talking about variables? Well, let's try to explain the difference here in a somewhat more concrete way. What is x? X is a variable. What are we doing? We're giving a value of 5 to that variable x. So see, we're going to put it in quotes here so we can sort of distinguish it, because we're going to have to use multiple equal signs. But I mean, we don't have to, but I'm going to anyway. Shouldn't be too complicated. X equals 5 is a statement. As far as we're going to, build up sort of a pseudo language, programming language. We'll, again, it'll sort of be a cheap rip-off of Python, I'm sure. But anyway, for general purposes, and talking about variables and just what is a variable in a general level in the context of computer science, x equals 5 is a statement. X, let's break that down a little bit. What is x? What is equals? And what is 5? So again, bring it back to mathematics here. We implicitly know what every element of this statement in mathematics is. We're saying that there's a variable, or there's a symbol, x, there's an operator, equals, which has an implicit function associated with it, and there's a constant 5. We're going to take this constant, we're going to put it in this symbol, and then any time afterwards that we use x, what we really mean is 5. And again, this, making it extremely simple. Obviously, mathematics is much more complex. It's as complex as you want it to be. There's no level of mathematics that, if you jump into lambda calculus, for example, and you're like, oh, this is real simple stuff. There's some level of of uh, of calculus or trig or whatever you want to say. There's some level of some branch of mathematics that will completely mystify you. So you can basically just dig down as deep as you want, and if it makes sense to you on some level, that's great. You dig deeper, starts to maybe not make sense, then you dig even deeper, and you have no idea what the hell you're doing anymore. So again, as complicated as you want it to be. Computer science, kind of the same way. Um, so again, we just sort of dissected this statement. There's three parts to it. There's a value on the left, there's an operator, and there's a value on the right. The operator in the middle here is what tells us what we're doing with the value on the right relative to the value on the left. And there's some subtlety there, and we'll get to that. But so in computer science, it's no different. We're making a symbol x, we're giving it an operator equals, and we're giving it a constant value 5. And similar to the mathematical example we used above, when a computer reads a statement similar to this, it's going to say, what's the operator? It's going to take that operator, it's going to grab the value on the right, in this case 5, it's going to assign that value to the symbol x. And then later on in the program, or whatever you're doing, anytime you put in x as a symbol, it will replace x. See what we say. A computer will assign 5 to x, put single quotes around it, and anytime after that, if the computer reads a symbol x, it will replace that value with 5. Yeah, 5. And that's it. We got really only 430, not even 10 minutes. All right, so we got a little time. So there's nothing crazy there. So we can see that this statement in computer science, not intensely or inherently different. They're fundamentally different. It's like the actual concept that we're trying to express in computer science here, it's not that much different than what we're trying to express up here in mathematics. There's a reason for that, as I alluded to. Computer science, direct descendant of mathematics. A lot of the concepts, most of the concepts, some people might say in computer science are they a rip-off of mathematics? No, but you're essentially, see if we can maybe make this more concrete. Why would you need to rip off or steal ideas from mathematics to express them in computer science to a computer to tell the computer what to do? Well, computers generally are faster dealing with huge data sets than humans. And we can remove the generally from that statement and just say, as a matter of fact, computers are always faster than human beings when it comes to dealing with large data sets and large values and things like that. There's just no way around it. Anyone who wants to argue with that point, if you can essentially prove that point wrong, then not only will you win a Nobel Prize, but you will completely turn the entire technology field upside down, and the Earth will probably explode. So that being said, why is the sort of the concepts of computer science so similar to mathematics? Because computers, way back when, they were essentially used to do complex problems in mathematics, and that's what they were initially built from the ground up for. There's other reasons, but we're just going to use that as a general mission statement. So, when the first mathematicians and engineers and whatnot were building up the computers, they, obviously they understood mathematics because they were doing electrical engineering and building switches and integrated circuits and vacuum tubes and drum memory and things like that. You can look all that up on Wikipedia if you really want to. And so they had a language, if you will, to refer to as far as how to express concepts in a way that made sense, sort of, to a human. So that, obviously there's some inherent subjectivity. X equals 5. It makes sense in mathematics. Some people look at that. If you have no idea what math is, then you'll look at x equals 5 and say, what the hell is that? But most people understand that on a basic level. And the conventions that mathematics has thought up is there's a syntax associated with math that allows you to express sort of arbitrarily complex concepts in a way, or just arbitrarily. It allows you to express arbitrarily complex topics in a way that is understandable to anybody who understands this basic sort of syntax. And so, they were building the first computers, and they thought, well, how the hell am I going to tell this computer to do this? Well, simple. Math already exists. The syntax for math exists. So all they did is they took the syntax for math, expressing concepts and ideas in mathematics. They dumped it into a computer. They designed the computers to be able to interpret that in a variety of ways. And we'll get to some of that, and then the rest of it we won't. And so that's why, in a nutshell, if you will, I'm glazing over, perhaps doing this no justice at all. And anyone who's a comp sci major or a professor or something, they're listening to what I'm saying right now and going, man, you have it completely ass backwards. And that's fine. But, again, you're free to make your own videos and explain this complicated sort of stuff to a general audience. But that aside, essentially that's why computer science reflects concepts of mathematics. You can say that computer science is built on mathematics. I don't think that would be an overstatement in any regard. So there'll be many times that you're trying to understand something in computer science or relative to computing in general. You could just type in variable here. It's why Wikipedia has a whole subsection for has a specifier, a disambiguation, if you will, for variable that says computer science instead of variable for mathematics, because the two concepts are so pervasive in their respective topics that you can't explain them both in the same article. And you have to differentiate between the two. Now, the concept is essentially the same, but the implementation and the under-the-hood details are so radically different for reasons that we just talked about that you have to have two articles to explain it. So let's see if Wikipedia agrees with us just real quick here. What's a variable in computer science? Computer programming. Variable is a storage location associated with a symbolic name which contains some known or unknown quantity or information, comma, a value. The variable name is the usual way to reference the stored value. Separation of name and content allows the name to be used independently of the exact information it represents. Very similar to what we do in mathematics. We'll go over that first sentence or two in the value specifically. Next video, we jump forward to the variable in mathematics. What's a variable in mathematics? In mathematics, a variable is a value that may change within the scope of a given problem or set of operations. It's a little more abstract, but the mathematics articles on Wikipedia tend to be that way. In contrast, a constant is a value that remains unchanged, though often unknown or undetermined. The concepts of constants and variables are fundamental to many areas of mathematics and its applications. A constant in this context should not be confused with a mathematical constant, yada yada yada. We're not going to deal with any of that. But you can see, according to this first thing, variable is a value that may change within the scope of a given problem or set of operations. We go back. We'll go back forward. We'll go forward again. What is it? It's a variable. Is a value that may change within the scope of a given problem. Just within that, we'll go back. What's a variable in computer science? It's a variable is a storage location. Let's scratch out storage. A variable is a location and a symbolic name contains some known or unknown quantity or information. Again, the first sentence of this article, the first sentence of this article, there is some discrepancy and whatnot, but they are essentially expressing the same idea, but they're expressing the same idea relative to different problem domains, if you want to be specific about it. So as far as the general concept, that's what a variable is in computer science. We talked about what is in mathematics, obviously. So this separation of value and location is the fundamental problem that we're going to deal with over the next couple videos, and we'll get right into that.